All right. Welcome to the May 17th, 2018 edition of our weekly Kubernetes community gathering. On these meetings, we have updates from SIGs and other awesomeness that pursues in the form of release notes and updates, as well as shout-outs. I'm Paris. I work at Google, and first things first, we typically do a demo. However, I think that they were unable to make it today, unfortunately. Last call, Raphael or Vasu, are you on the line? All right, they are not on the line. So what we will do is go ahead and proceed into release updates. If they do come on the line, we can gladly take them at any time. Release updates, Josh, I think I just saw you.
Howdy.
Howdy.
So we are in week 7. So just past the halfway point for the 111 release cycle. Our next deadline is going to be next week, May 25th. The docs team has asked everyone with the feature to create placeholder PRs if you don't already have an actual doc PR, which is, of course, preferable, but at least have a placeholder PR by the end of next week. The beta 0 should have been released last night. I didn't check the status of available files, but we kicked off the process to release it late yesterday afternoon. So that is our first beta. And the really exciting thing about that is, thanks to the effort of a whole list of people, too long for me to actually read out, but I put them there in the notes. So a whole bunch of people came together to give us relatively clear test signal, as in only a couple of blocker scalability upgrade tests still failing, and those for known reasons that just take a little bit longer to fix. Very few open bugs. So we feel confident in both releasing the beta and, more importantly, for people working on 111 features, delaying the start of code slush and code freeze, which means effectively adding one more week of development and cutting a week from the code freeze period. Hopefully this can become a standard in future release cycles. If we can keep our tests generally passing, then code freeze can in fact be very short. Maybe even get it down to a week. We will see. Code freeze will actually start on May 29th. Then, sorry, not code freeze. Code slush will start on May 29th. And then code freeze will start on June 5th. And again, everything is up in the calendar, has been updated, and everything is up there. Thanks a lot. Keep working on 111 and keep those tests passing. One area I do want to call out is, again, like always, if we have anybody in here who is a performance or performance testing geek, SIG scalability could really, really use help in improving the performance tests so that we have faster performance feedback to contributors and thus can fix performance bugs faster and with less effort. So thanks a lot, and another update next week.
Awesome. That's great news. Congrats to everybody that's on the release team and everybody that's been helping out with tests. I don't believe we have a 110 release update. Last call if anybody's on the line to give that update. All right. We are on to the next portion of our day here, SIG updates. I know I saw Bob. Bobby, are you on the line with SIG scheduling? If not, Bob, do you want to take it for scalability? That would be a good intro from Josh's Help Wanted.
I'm here. Paris, I'm here. Do you hear me now?
Yes, I do hear you. Bobby, is that you?
Oh, okay.
Okay, cool.
Yes. Okay, for SIG scheduling, I can give an update. By the way, how much time do we have?
You have up to 10 minutes. So
okay, that's good because I can now explain some of the features with a little bit more detail, perhaps. Okay. So for 1.11, essentially, we have several features that we would like to move to beta. Priority and preemption is one of the most notable ones. As most people know, this allows us to specify priority of pods, and when a cluster is under resource pressure, pods with the highest priority can be scheduled at the cost of removing some of those lower priority pods from the cluster. One of the biggest blockers for this feature in the past has been the fact that we wanted to get some actual mileage from this feature. Luckily, this, we actually ask a lot of people in the community as well as some of our users in GKE to try this feature. Some people tried, but we were not able to get useful feedback, or we didn't have proper channels to communicate with them before. This quarter, we have been able to try it in one of our internal GKE users, and we haven't seen any problems so far. So it feels like we can move it to beta and enable it by default in 1.11. Another notable feature is equivalence cache that Jonathan is working on. We still think that it's on track, right?
I'm honestly not sure. It's been feature complete for a long time, and we're just trying to harden it with like better testing and fixing some subtle bugs.
Sure. Yeah. So basically, the idea here in equivalence cache is that it's an optimization for the scheduler. The idea here is that once you have evaluated some predicates for a pod and predicate conditions that basically scheduler evaluates to determine whether a node is feasible for running a pod or not. So once we have run this predicate for a pod, if there is a second pod or more pods in a cluster that require the exact same type of resources or same conditions for scheduling, we don't need to reevaluate the predicate as long as the cluster conditions have not changed. So basically, for example, a pod that requires 2 CPU and cannot be scheduled anywhere in the cluster will not be able to schedule anywhere as long as the cluster remains the same size and no other pod is getting terminated in a cluster. So there is no point in reevaluating this predicate again and again if there are many pods waiting for 2 CPUs. That's the idea behind equivalence cache. So basically, scheduler caches the results once it evaluates the predicate and keeps the cache as long as the condition of the clusters from the point of view of scheduler remain the same. Once the conditions change, then the scheduler invalidates the equivalence cache. So there are some subtleties involved, both in terms of race conditions in invalidating the cache, as well as invalidating the cache at the right moment. Also finding what would be the right metric to determine equivalency on pods. So there were some subtleties involved. We are trying to hash out all the little corner cases, and hopefully we can move it to beta in 1.11, but we are not 100% sure yet. This is another item anyway. There is a big effort in the community as well as inside Google to design gang scheduling. Gang scheduling is a feature required by various workloads, notably by machine learning as well as like Spark. So the idea here is that we would like to schedule a number of pods together. If a certain number of pods cannot be scheduled all at the same time, there is no point in scheduling a smaller set of them. So currently a scheduler only schedules one pod at a time. We would like to be able to make some changes so that we can guarantee that either the whole gang can be scheduled or we don't schedule any. This is something still in the design phase, although there is an implementation of a prototype in one of our incubator projects, Cube Arbitrator, that implements kind of a simple version of this, which basically specifies only a minimum number of pods that should be scheduled together, and it works reasonably well so far. But we would like to basically collect all the requirements. For example, one of the things that have recently come up is the heterogeneity of the gang. So some of the pods in the gang may have different images or require different scheduling or have these different scheduling properties.
I have a question.
Yes.
There has been talk off and on about using some kind of, like, I know gang scheduling has a very specific meaning in HPC, which is what you've just described, but there's been some discussion about using a gang scheduler-ish sort of approach in order to improve scheduler throughput. In other words, just do like lots of batches of scheduling together. Are you viewing these as related, as like one might be a step in that direction, or how would you view that? So
there is an incubator project that actually trying to basically build a scheduler that does this. I guess you're talking about the idea of the firmament scheduler. Is that what you're referring to?
No, I mean that's another scheduler, but I think I was really asking the question in the context of optimizing the throughput of the current scheduler in general.
Yeah, that's right.
For optimizing the scheduler throughput or optimizing the workload throughput? Is it like for batch queuing or?
Yeah, batch queuing. I was just asking if they were sort of related or whether they were kind of separate things. That was all, really.
So we are not really doing much in terms of batch queuing, although it is also in our basically plan to implement that as well at some point. But definitely it's not the first step for gang scheduling at this point. However, we have another idea of improving the throughput of the scheduler by looking at a number of pods instead of one pod at a time. That's basically the same idea behind firmament scheduler.
That's a performance optimization, though, right?
Yes, that's
not a workload throughput.
Correct.
Optimization.
I was
thinking
about the throughput optimization, really, as whether that was a step along the way, required, or separate, I suppose.
So you're also talking about scheduler throughput, I believe, right? Yeah, performance optimization there. Right, so that effort is going on, but basically engineers from Huawei are working on this. They have run into some challenges, technical challenges to support all of the Kubernetes API, notably pod anti-affinity, which is like a symmetric and has caused quite a bit of headache for them to implement it properly when they are considering a batch. Other thing that I've heard from those guys is the fact that although the throughput of the scheduler or algorithmic part of the scheduler can be improved, when they are trying to bind all these pods, they still see a lot of the slowdown, and the performance optimization is negligible, basically. So they don't see a whole lot of throughput improvement after they add all the features. We're still working on this, so it's not we are not completely oblivious to it, but we don't see a whole lot of improvement at this point. Okay, so we are working also on moving a couple other features like taint node by condition and also taint-based eviction to beta as well. Another big effort is to build a scheduling framework that is still in design phase. We are moving that forward as well. Pod scheduling policies is another big effort that has been kind of blocked by very different opinions that everybody in the community has. Some people believe that we should do it with OPA. Some people have some opinion about how to design it, how to design the API in one way or the other. So we're not seeing a whole lot of improvement in that area. There is a design proposal already written, but as I said, there has been so many comments, and every person has a different opinion about it. So we are hopefully gonna get to consensus at some point and move it forward as well. These are pretty much all the features that I wanted to talk about. back to those.
We can afford maybe one question from anyone for Bobby. Last call. All right. Bob, you're up with scalability. Thanks, Bobby.
Thank you.
I think we should continue the habit of having like all Bob SIG.
Have it all, Bob. What was that?
Hang on a second. I'm going to try to share my screen.
Sure.
Can you see that?
Looks good on my end.
There it is. Oh, somewhere in here there's a full screen, but I think I'll just forge ahead without it. So I was invited by way of time savings to recycle some KubeCon content. I'm going to do that with some small updates. Hopefully, some of the stuff that we talked about at KubeCon EU will be of interest. Just a little background: we have found that when we do the SIG updates at the conference, that it's a little bit more user-oriented and a little bit less developer-oriented, but I did put some more developer-oriented bits in here as kind of a slight update. So, right. So I think I put the slides, by the way, in the SIG Scalability channel. So if you want to take a look at them there, there's also a link to the YouTube video from the SIG intro that we did. Shout out to Sham, who last at Austin and in Copenhagen as well did a bang up job of running the session. So thanks to him. I'll go through this pretty quickly. This is just our kind of standard SIG update. Like, this is the stuff we work on. Here's our logistics. These haven't changed in a while. I'll go through that pretty quickly. Stop me if there's questions, I suppose. Again, one of the things that comes up a fair bit is just with users, especially just understanding like what and how gets tested on the project. And perhaps the audience here is also someone interested in this. Probably a good refresher here. Probably the interesting bits here are what the schedule is for the big runs. So there's an even odd day schedule on the 5K performance and correctness runs. So there you go. So I'll skip about this. I'll skip over this here for a second. I think one of the things that we've found helpful, especially, is that in the user community, there is a fair bit of obsession with nodes, number of nodes that are supported. We found this pretty commonly. So one of the things we try to do is educate the user community that number of nodes is not the only thing, that there's a bunch of different performance axes here. These are not the only ones, but I think these are the ones we feel like are the ones that we see issues around. And so we're trying to introduce this concept of the performance envelope and how if you stretch your performance in one direction, it's going to shrink the performance in another. One of the things that I think we should do is actually explore the space a little bit more so that we're able to give our user community a bit more guidance about if they stretch one of these axes in one direction, how far, what actual impact does that have? So this has been a useful way to try to get users up to speed on, hey, there's more than one thing that matters. And then I won't go through these here. I think the group here has seen them, but one of the things we like to do is just kind of show people what kind of publicly available resources there are for them to look at. Some of you can explore this on your own, perhaps afterwards. And again, we find a lot of more beginner users like to show up and hear about what the what are the pro tips. So these are some of our pro tips. etcd version locking is one that comes up a fair bit. Very common for newer users to just install the latest version of etcd and then have problems. Also, there's not very good awareness of KubeMark outside the developer community as a possible resource for how to do cluster qualification and testing a little bit more cheaply and efficiently. It's great for pipelines. Okay, so little bit more here. We kind of skipped over this in KubeCon, but I'll highlight it here, which is there's some good reading here if you're interested. As Josh mentioned, if there's some scalability geeks here that want to look at this, there are some guidelines that are probably good for everybody. Take a look at those. The performance regression study that Sham did is, I think, a fascinating read for anyone who has even the slightest interest in this. So take a look at that as well. That's a good bit of work. That's a good piece of work. If you're interested in deeper dives on the SLOs, have at it. And then kind of work in progress stuff. I think 2 bits here that are worth a mention. One is that there's more work going into real workload testing. And I've put the pull request here. This is cluster loader work. And then the other thing is that we've been making decent progress on getting more scalability testing into the pre-submits. I think I believe the current status is that we're kind of closing on feeling like the actual pre-submit tests are themselves in good shape, but there's still some concerns around how long they take to run. And clearly we need to make sure that we're not impacting project velocity by adding too much wall clock burden to the testing there. And then one thing that we've been poking at a little bit is just trying to help users do their own performance testing. And so Sonobui is an interesting way to do that. So shout out to the Heptio folks there. And I don't know how long that was, but I'm done. Hang on a second, were there some questions?
Anyone have questions for Bob?
I just posted one question in channel. I wondered if the slides were available online.
I did post those in the agenda.
Yeah,
so.
I'll throw them in the agenda. They are in the SIG Scalability Slack channel at the moment. I posted them there this morning. So if you want to just quickly find them after
there
the
should be a link there should be a link to the presentation just given is now in the community meeting. It's the first bullet point under scalability. It says slides.
Excellent. Thank you.
Great. All right. Thanks.
Actually, I do have a question. Given that a lot of the limitations on our scalability come down to etcd performance, how much active work is there with the etcd developers to specifically look at the performance things we're running into?
Others may have a different perspective here. I would not say that performance is bottlenecked on etcd overall. It kind of depends again on how you're running. But my point, the point I was trying to make was that we have seen performance regressions with regards to different versions of etcd. So we're just urging caution to not just install the latest version of etcd, point your cluster at it, and expect that things are going to work right. There's a lot of testing that's done, and if you go back through and look at the PR history, you'll find, more than one case where we had to revert on an etcd version because there was some performance regression that happened. So my comments were really more about regressions and stability than they were about performance issues per se.
Clayton also had a comment too in chat about doesn't think etcds are a problem in general. Only thing I'm aware of is the range locking stuff that's being improved in 3.3, 3.4.
Right. Okay.
Last call.
Sham's very deep in this, so I would disagree with him only at my own peril, Josh. Just reading your comment here. There may be certain scalability tests that where etcd is stressed out. I can't actually speak to that. He'd be a better person.
All right. And I just got a ping from Daniel Smith with API Machinery that he's running late. Oh, he just pinged me. He is here. All right. Daniel, if you are on, take it away for API Machinery.
Hi. This is the API Machinery SIG up. Yeah, so SIG update. Let's see. We're doing stuff. I'll just list some things that we have done recently. David made a new dynamic client as a streamlined interface. The old dynamic client will be available in the client library under the deprecated dynamic client directory, so it's still there.
Go client.
Yes, the Go client. This is the unstructured one that you'd use for a CRD or a type you don't know anything about. Yeah, so that's coming. One thing to know about that is that the client-side QPS rate limit behavior has changed. So if that sounds like something that you might care about, you can go read the release note. What else? We're still working on putting the first of several choices for CRD versioning. And we discovered a sort of a late-breaking discovery to our design for versioning priorities, but I think we can still get the no-op conversion in before 1.11, so look for that. I think those are the two major things. There was something else I was going to. And I'll give an update for the apply working group since I'm here, which is we're using a feature branch. We've made some changes. We're trying to put everything in master that can go in master. Like if we do a refactoring, that all went in master. We're not going to reintegrate before the 1.11 cutoff, so we'll keep working through the code freeze because we're in our own feature branch. And I should say that our use of a feature branch is somewhat experimental. Don't everybody copy us yet.
Don't anybody copy it yet.
Yeah. Yeah. I think that's it.
All right. Any questions for API Machinery or the Apply Working Group? Or any of the other SIGs that presented today? All right. So we actually are flip-flopping the agenda and the demo is on. I see Vasu and Raphael right now. Thanks for joining us, y'all. So you have 10 minutes, and if you want to go ahead and share your screen, we can you might want to adjust your terminal view to make it bigger if you have any terminal stuff going on.
Thank you, Paris. Yeah, my name is Vasu, and I have Raphael here with me. And we want to give you a short demo about our project Gardener. So Gardener, we internally also call it the Kubernetes botanist for reasons which will become evident later, has a mission statement which was kind of derived from the needs of larger enterprises like SAP, where we need to operate really many Kubernetes clusters across all of the various public cloud providers, but also on private clouds, right? So now that's definitely a mouthful, but before we enter into the demo, we want to give you a quick overview of Gardener's architecture and its setup. I think in this round, we don't need to explain self-hosting, but we do apply a special pattern around self-hosting, which could be termed control plane as a service. The fact Gardener is completely open source by us, and it's mostly written in Go, and we ensured that it's a first-class citizen of Kubernetes itself so that we don't actually need other control tooling around it. Okay, so now to the infrastructure setup itself. The first thing you need to do is to bootstrap an initial central cluster, which we call the Garden cluster. We use an internal tool called Kubify for this purpose, which we also open sourced. So once you have the initial Kubernetes cluster, the Garden cluster going, you deploy the dashboard and the Gardener components. The Gardener is implemented as an extension API server. Next, we need a seed cluster on the target infrastructure. Now note that we do not need access to the target infrastructure as a service API. We only need to connect to the Kubernetes cluster API of that seed cluster. This enables us to piggyback and get access into private cloud and on-premise setups. We deploy the control plane components in a namespace and make use of the isolation features which are available there. The first thing we, of course, deploy is an etcd with the backup sidecar, and then obviously all the other control plane components. And with the load balancer active, you almost have a working control plane. In our setup, we always give every control plane a dedicated Prometheus monitoring and logging setup as well. Now to the end user cluster itself, right? So because we seed the control planes in the seed cluster, and now it's ready to sprout, we call it the shoot cluster. And for accounting and isolation purposes, it's typically located in a different account on that target infrastructure. And we first execute a Terraform job with inner access to the IIS API and prepare or just verify that the network is set up correctly. Then we let another component, our machine controller, materialize the nodes. The machine controller lets you order virtual machines via Kubernetes custom resources. So it's a primary citizen of Kubernetes itself. And we also connected the autoscaler directly with the machine controller. And I think the rest is pretty clear. Maybe the only thing notable is that because we have an air gap in between, we need a VPN sidecar such that the API and monitoring get access to the nodes. So I think now it's desperate time for a demo. So Raphael, you go ahead on the CLI.
Yeah. So hi everyone. I will try to give you a quick overview of how that whole looks in action. So I'm now logged into a Gardener dashboard in one of our dev systems, and I'm targeting the CNCF project, which I created here for the demo purpose. I have pre-created 3 Kubernetes clusters, 2 on AWS, 1 on GCP. And at a glance, I can see the most relevant information for all of these clusters. So for example, this one here has an issue because the cloud provider credentials are incorrect. This one is healthy. I can also drill down into more detailed information, more detailed health checks about the seed control plane, all the nodes and all the system components. We also have a detailed cluster overview, which you can see here when we click, where we can also get access to the dashboard, to the monitoring system, or download the kube config. So the rest of these panes here are basically for project administration, managing the members and the secrets. What I want to show you now is the administrator features of that dashboard. So for that, I quickly switch to terminal. And you see I have pre-configured my user account to be an administrator by just modifying a cluster role in that Garden cluster. And with that, I'm able to see all the projects managed by this Gardener system on this landscape. And I can also drill down into the projects and see all the clusters which are created there on the different target infrastructures they have, and get detailed information here. I even have access to the clusters which have issues, so I can filter by them which we have problems. As an operator, I basically only care most about them. And I also have possibility to a journaling and ticketing system where operators or administrators can pin certain messages to their clusters. Okay, let's take a more technical view. I'm here in the Garden cluster, and we run basically the Garden namespace, the API server extension, the controller manager, and the dashboard as normal Kubernetes pods. And the project which you just saw is here represented as a namespace where I can use regular kube control commands as it extends the Kubernetes API to just list all my clusters. The Gardener creates secrets in that namespace for the kube config and SSH keys so that the user can conveniently download the credentials and access information. And what we now basically want to do is to create a cluster via the dashboard and show what happens actually in the various seed, shoot, and Garden clusters. So for that, I prepare here a watch. And also in this pane, I have prepared a watch for the seed cluster, where you already see there is a namespace for the cluster 2, which already exists. And we're now creating via the dashboard a new cluster. Let's call it demo and see what happens there. So basically the name is demo here, and the worker pool is selected AWS.
So you have to put the monitoring away.
Yeah. It seems like we have a problem currently. So usually you can select the target infrastructure here, AWS, GCP, Azure. You can configure your worker nodes and patterns and maintenance information and create the cluster. So I have already pre-created this one. So let's take a look what's running there. The technical representation of that cluster is basically like a normal Kubernetes manifest. We extended the API by these shoot resources. All the cluster-specific information like add-ons, network configuration, regions, and so on are managed in the spec section. And in the status information, the gardener puts the last available health checks, the conditions, just like for pods, and it reconciles the cluster state every 10 minutes. So here in that seed cluster, let's take a look at what's running there. As Vaso explained, so that's now the complete control plane managed with the seed for an end-user cluster. The etcd is a stateful set. We have our regular Kubernetes components running as pods here. We have some monitoring components like Prometheus and the alert manager, and we also have the machine controller manager. So as said, it extends the Kubernetes API with custom resources, machine resources, which are resulting in actual virtual machines in the end. So here I'm targeting the shoot cluster. And we basically only install the most needful add-ons and components which are required to run the cluster, plus the additional add-ons the user wants to configure in the shoot manifest. Here's also the VPN component that I mentioned. So, and we are basically part of the cluster API working group as the machine resources, which we already have in place and are already in production, are also developed by the cluster API working group, and we are trying to contribute our learnings back and merge what we have learned there. Yeah, so that's pretty much it. I invite you all to take a look at our homepage or also read our just released blog where you can find more detailed information. Or also just reach out to us if you have any questions. Thanks.
No. To stop this one.
All right. Any questions? Last call for demo questions.
Is the project stable, or is it still like in development?
Well, we use it internally. It's kind of the open source project is still in development. There are a lot of additional features coming in, but we think that you can use it for non-productive use today already.
Cool, thank you.
I have a question too. I was wondering if you plan on any bare metal type support.
Okay. So when you looked at our architecture diagram, we more or less piggyback on an infrastructure layer, which is provided by a partner like SUSE, for example, or other partner companies. And more or less, if they offer us an infrastructure API, which gives us access to bare metal, we can really piggyback on that. So that's kind of the division of work we're currently setting forth with.
Oh, that's great. Looks impressive.
All right, last call for the team. Oh, VMware support. It looks like in the chat someone's asking.
Oh, yeah. So this is an interesting question. We're actually talking to our colleagues, our partner at VMware, and we could actually do it ourselves, indeed, but we also want to have support in that. So we're actually waiting for our VMware colleagues to jump in and do that for us, right? And this is an open source project. I think this kind of we are at the moment kind of consuming a lot from the Kubernetes community. Thanks a lot for that. We're learning a lot, and this is kind of our way to give back, I guess.
Awesome. Thanks again, y'all, for coming on. All right, now we are on to the announcements part of our day. First, shout outs, a couple warm welcome messages to Liz and Chuck Ha for their journey in joining the Kubernetes organization. They both have been having a big impact in SIG cluster lifecycle, and that's per Stealthy Box. Welcome to you both. It looks like Chant Z and D Anderson for a great conversation on bare metal options and concerns, and in some Slack channels this week. Also, a quick shout out to Liggett, Master Wrangler of End-to-End Bug Test. Jordan has fixed many fun bugs. Looks like there's even the link to the bug in there for folks that want to check that out. And Keeping Things Green, that was from Ben the Elder. And then Teague Cole says, as a new contributor, they can 100% endorse Carolyn for being really good at bringing on new contributors. I'm guessing this is for SIG Service Catalog, and dedicating a lot of time and effort to make sure that they're successful, which is an awesome shout out. So thanks, Carolyn. And then we also have some help wanted items today. SIG UI is looking for new contributors to go up to the ladder to eventually become maintainers. Start with an open issue first, and then also feel free to reach out on the mailing list and Slack channel. They do have some current maintainers that are very interested in mentoring others. So if JavaScript's your thing and you like the dashboard, please feel free to reach out to SIG UI. And we just heard that SIG Scalability is also looking for contributors. Reach out through their various communication channels and open issues if that is something that interests you as well. And then also with contributor mentoring, we are looking for more mentors. We have 7 mentoring programs now, and half of those are built out with the other half in progress. If contributor mentoring sounds like your thing and you want to check out all of the cool programs that we have, feel free to fill out that form. Our next mentoring initiative is Meet Our Contributors, which happens on the first Wednesday of every month. So June 6th is our next event for that. And that's a YouTube live stream event where it's mentors on demand. You can ask questions to contributors, questions like, why is my test failing? How do I become an approver? And everything in between. So join us for that. And then KubeCon follow-ups. The video and slides are up. And thanks to Cloud Yuga for putting that together in a GitHub repo of all of the videos and slides. That's pretty awesome. So it's a comprehensive list. And then some quick other comments. Don't forget to check out discuss.kubernetes.io. It's a new communication platform that we are testing. This is an open source tool, and it's very similar to a forum or a message board, but please post messages there so that we can have some public discussions. And then last but not least, we are going to do a contributor Ask Me Anything during the community day at DockerCon, which is coming up June 13th in San Francisco. If any contributors are going to DockerCon and would like to pop in and help us answer questions, feel free. This is an unstructured 3-hour window, just taking questions from folks at DockerCon that walk in. Does anyone else have anything to add, whether it's shout outs, help wanted, or any other announcements that they'd like the floor with? All right, looking in chat, and doesn't look like anything's there. You might get 15 minutes of your life back. Last call. All right, that's it. Same time next week. We will see everyone again. You have 15 minutes of your life back. Thanks, everybody, and happy Thursday.